Look at this plotted velocity versus time graph, and there are two curves are there. No, one there are two graphs curves are there. One circle, other a straight line. First, you assume the situation. What is the situation? Both the blocks are of mass 1 kg, and one of the block is moving, and the other block let it be at rest. Then you go and collide. Okay, now I'll discuss the theoretical idea, then I'll come back to the problem. First, let me focus on the theory. Theory involved this. Theory involved means just like some better to have some discussion on this, then we'll enter into numerical. So let's assume that there's a first block because both are identical masses. So let they be placed on the ground. They collide, and this is moving with a velocity v naught, and after impact they will move with the velocities, let it be v2. So let this be the situation now. Now let me apply conservation of linear momentum. Then according to this, mv1, mv2. So v naught equal to v1 plus v2. This is the equation 1. As it is elastic collision equal to 1. So can we apply conservation? And let me plot this graph. How the graph for this equation 1 will be. How the graph will be different. So the curve will come. So let this be the v1, let this be v2. And this is v naught, this is v naught. Is it okay? When v2 is 0, initially when it is at rest, so the one was moving with a velocity v naught. After impact, the two will move with a velocity of v naught and v1 will become 0. I think, is it okay? I think it speaks a lot about everything, the collision, no? Initially, before collision, what is the velocity of the object? Or this is v1. Speed of the first object. Before collision, what is the velocity of the first object? V naught. After collision, what is the velocity of second object? That is equal to V naught. And what is the velocity of first object after collision will be 0. We know elastic collision, and this is a test. So we are very sure that after collision, V1 will be 0, V2 will be V naught. Will I agree? So when I plot this, so here, so what is V1? Speed of the object, speed of the incident object after collision. What is V2? Speed of the second object after collision, that one. So when I plot them, I'll get this one. So finally, we know V1 will be 0. So that everything I'm showing graphically, like, will I agree this? So according to this, the equation should be V2 or V1 is equal to V naught minus V2. V1 0, V2 equal to V naught. V2 0, V1 should be equal to V naught. That is one condition we have. Let's see that what is the use of this. I plotted, I ended. So let's go for another as the elastic collision. So kinetic energy should be considered for E equal to 1 strictly. equal to 1. For equal to 1, mv naught square by 2, mv1 square by 2, mv2 square by 2, or this is equal to v1 square plus v2 square. So this will be some sort of a circle, no? Shall I go for a circle? What should be the radius of circle? Again here, along y-axis, what I'll plot. This I think will take v2, v1, anything let it be. So this should be v2. What should be the radius of that circle? Symmetrical diagram. Let me put it. We have like this. Is it justified? Just I'm taking help of mathematics, geometrical way of interpreting this collision when two blocks are identical, and if it's elastic collision or inelastic, it will help us that one. So let me superimpose both. So what is this value? So shall I put this is equal to V naught, and what should be this value? Equal to V naught. When V2 equal to V naught, what should be the velocity of the first object? Should be 0. And when velocity of the first object is V naught before collision, what is the state of the second object? It was at rest. So the graph speaks a lot here. No? I'll superimpose both. Let me superimpose both on one diagram. Let me superimpose. So now I'll bring this straight line. This is V2. This is V1. And what is the value of this? V naught. This is V naught. Okay, let's superimpose both here so that energy as well as this equation 192 are superimposed on one particular graph here. What is the meaning of this particular graph? What is the meaning of this? How to interpret here? Now there are 2 points of the straight line will intersect with the circle, no? This will be. So what do that particular point will indicate here? So what about this? After impact, the velocity of the second object will be V naught. That of the first object will be 0. Is it possible? Yes, this is possible. Now let's interpret. And after collision, the velocity of first object will remain V naught. That of second object will remain as 0 only. Is it possible this? Mathematically okay, but physically what happens? The first object should pass through it. So therefore, V1 equal to V naught means don't go for the initial. I think come out of this. What is the interpretation? How you have to graph? What is this graph? What are V2, V1? Collision of objects, speed of objects after collision. This is after collision, before collision. And what we are plotting is after collision only. This is after impact. What is this graph? We are not bothered before impact. Before impact, we are very sure. So therefore, how to interpret V1 equal to V naught, not like before collision. It should be for after collision only. Now, this is after impact. I think now we are in a far better position. So there are 2 things are possible. There are two values are there. Here open after impact, the second object will move with the velocity of first object and the first object will come to rest. Is it okay this particular point? What about this? After collision, the first object will continue to move with the same velocity V naught, while the second object will be at rest. When do this will occur? the first object will pass through the second object, will penetrate through it. I think physically this is not possible, no? How to interpret this particular point? After collision, the first object will pass through it. Physically, it will pass through it and it will come out with the same speed. And whatever second object will be there only. This also happens. But science, what happened till now, we are not in a position to construct such a material. But theoretically, it says yes, it's possible. It's also you have to take it to be collision. Means, I think in movies they show no, a person will pass through a wall. It's a theoretical. Practically, we are unable to prove this one. We are not in that position to prove that one. But the theory suggests yes, it's possible. Are you getting the idea now? See, some very good concept is involved. There is also a collision. If an object passes through other object, it is also said to be collision. That's what this numerical is telling us. So what shall I say? Not possible. Practically, got the idea, no? Practically not possible this is. So what actually happens? The object should pass through it. I'll put it no. So let me call that a unique points A and B. So for B, how the situation will be? For A, what actually happens? A, it will be like this. Huh? M, we know this is the first object. This is at rest. This is the second object. After collision, this will come to rest. And this will move with a velocity for point A. What about for point B? For point B, how you have to interpret for point B? After collision, this will be at rest. This will just pass through it. So what's happening here? Object 1 will penetrate through the object 2. Or block. Block 1 penetrates through block 2. This interpretation, this is not possible. I'll write clearly here. So therefore, when in collisions, whenever you solve mathematically, I think you should be very careful. You should be able to interpret the end answers very easily. This is about the velocity of second object and the first object when you plot it. So the equation one what is plotted. So what is V2? Velocity of the second object after impact. What is V1? Velocity of the first object after impact. Then I took the as it is elastic collision equal to 1, then applying conservation of the kinetic energy. Then I plotted one graph and it's a circle. The radius of the circle is what? The initial speed of the particle 1. I'll superimpose both. Then the straight line, what happened, will intersect the circle at 2 points at A and B. So what is that A? A is what? After impact, the second object will move with the velocity of first object and the first object will be at rest. That's what the point A indicates. And it's practically possible. What about the other intersection? The point B. So I'm saying practically not possible. What do you mean by that? The first object will pass through the second object and second object, nothing will happen to it. This is also a collision. Huh? I'm saying collisions, it's having a lot of interpretation. What we know is that a body goes and collides. No, this is also a collision. If a body penetrates through other body without changing the momentum of other body, then also you can call that as collision. Even the momentum of that body changes also, still it is said to be collision. Here we have taken a situation where the momentum of second body will not change. But in some situations, it will also change. Theoretically, it is. Practically, till now, we don't have anything that one. Okay, all of you getting this? So now this is about the interpretation of the graphs here now. So how to interpret it will intersect. Now let's come for the different types of graphs here. Now, if the perfect inelastic collision, how the graph will be? If the perfect inelastic collision, how the same graph? Still the problem not got over. So let's go for no perfect inelastic collision. How the graph will be? Come for this. Just as a mathematical one, you're supposed to analyze through mathematics here. And now I'll give two graphs for you. Which is correct is what you're